Hi and welcome to Pre-Calc 30 with Miss Verity. Today we're going to be looking at 11.3 The Binomial Theorem. So it relates coefficients to the expansion of some sort of binomial, hence, binomial theorem. When we expand our powers, basically, rather than having to multiply this thing actually fully out, we have a way to simplify and just get us straight to the answer rather than multiplying 100 times. So exploration 1 is expand to determine the number, or determine each of the following, express in descending order. So all expand means is actually do the multiplication. Express in descending order is where we go alphabetical order, highest power to lowest. So spoiler alert, these are what these actually equal. So this equals 1, anything to the power of 0 is 1. This is just x plus y. We get x squared plus 2xy plus y squared. For this one, we end up with x cubed plus 3x squared y plus 3xy squared plus y cubed. For our fourth power, we end up with x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. And our last one, x to the fifth plus 5x to the fourth y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the fourth plus y to the fifth. So if we were to multiply those out, that's what we would get. Identify any patterns. Well, the biggest pattern is that our powers decrease, because this would technically have an x to the 0. We have a cubed, a squared, a linear, and a 0. And our y's increase. We have a 0, a 1, a 2, and a 3. That's the main pattern. Next up, we are going to determine the following combinations. So using your calculator, figure these out. So they equal 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So identify any patterns. Well, the pattern is we start off with a 1. Okay, that's great. The next one, we have 2 1s, but then 1 plus 1 gives us 2. So 1's for our end. 1 plus 2 gives us 3. 2 plus 1 gives us 3. 1's on the end. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4. And again, starting with a 1, we have 4 plus 1 gives us 5, 4 plus 6 gives us 10, 6 plus 4 gives us 10, and 4 plus 1 gives us 5. This beautiful little triangle we just created is called Pascal's triangle. It's a triangular array of numbers corresponding to the number of ways to choose R elements from n objects. It's connected with the expansion of binomials. So if we were to fill in these patterns, so we start with a 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35. Oh, something happened. Nope, 35. We're good. 21. Oh my gosh, 7 and 1. So on and so forth. And it would correspond the exact same way for our C's, because that's what the C's literally correspond to the actual numbers. So that leads us to the binomial theorem. It can be used to expand any power of a binomial expression. So given a binomial raised to a power, it is equal to, so this formula looks crazy, but I'm just going to talk through what it is versus going over the formula itself. To figure out our terms, we can use that formula, but we'll come back to that. So we're going to expand x plus 2 cubed using binomial theorem and Pascal's triangle. So we're going to start off using the binomial theorem. The binomial theorem essentially allows us to use Pascal's triangle, but so how this formula works is we've got, if we're going to do our general form, where so our a is equal to our x in this case, our b is equal to positive 2, and our power is 3. So we'd start off with our combination. So in our combination, we take our power and we have c and we start at 0. So our power is 3, so c 0. We have our first term to the highest power, and our second term, which in this case is 2, to 0. For our next term, we're going to increase this, so 3c1. Our first term, so our x again, is going to decrease a power by 1, and we're going to increase our second term by 1. We then are going to add 1 to our next part, so 3c2. Our x term is going to decrease by 1, and our other term is going to increase by 1. We then have our last term. You're going to know to end when your numbers match. And also your first term should get down to 0, and your second term should then be at your highest power. And now we're just going to evaluate it. Well, these, like our combinations, they essentially correspond to Pascal's triangle. So you could either throw them in your calculator, or knowing that this is 3, the power corresponds to, so it's like your power plus 1 is your row of Pascal's triangle. So first, second, third, fourth row. So that's what all of our numbers should correspond to. So 3c0 is 1, x cubed 2 to the 0 is 1, plus 3 x squared times 2, plus 3c2 is 3, we're at x, 2 squared is 4, plus 3c3 is 1, x to the 0 is 1, and 2 cubed is 8. So just to simplify and give us our nice pretty look, x cubed plus 6x squared plus 12x plus 8. And so for a cubed, sometimes it's a lot of work to actually multiply it out. Well, using Pascal's triangle or our binomial theorem, we can just get our answer pretty quick. So we're going to expand this next one. So again, you could use your combinations. So we could use our combination of our power is 5, so 5c0, 5c1, 5c2, so on and so forth. But we could also just go to the 6th row. So 1, 2, 3, 4, 5, here's our 6th. On your pink sheet, I believe you have it up to the 1, 2, 3, 4, 5, 6th row as well. But you can use your brain or your combinations if we go further than that. So here, if we're doing, again, a plus b to the power of n, our a is x and our b is negative 2y, and our n is 5. So we're going to start with, I know these are going to be my coefficients. So 1, 5, 10, 10, 5, and 1. I'm then going to do my first term to my highest power, which is 5, and my second term to my lowest power, which is 0. And we are adding all of these terms. I'm going to add my addition signs in next. So next up, we've got 5. We're going to decrease our A term, and we're going to increase our B term. We're going to decrease our A term, and we're going to increase our B term. And we're going to continue that. You don't need to put to the power of 1, but if you want to, go for it. And you also technically don't have to put to your power of 0, but again, go for it. So now we're just going to evaluate. Remember that the negative 2y is in brackets. So when we do odd powers, that is going to end up being a negative. If we do even powers, that's going to be a positive. So here we've got x to the 5th plus, depending on what my power is, I might simplify in 2 steps. But this one I might honestly. This one's going to be negative 10 x to the 4th y plus this one, I might leave it as this and then have my positive 4y plus 10x squared. This is negative 8y cubed plus 5x. I'm going to have to the power 4, 16y to the 4th. Plus, I've got 1, and I'm going to have 16 times 2 is 32, negative 32y to the 5th. And so now I'm going to simplify my final version. So negative 10x to the 4th y plus 40x cubed y minus 80x squared y cubed plus 16 times 5 is 80 xy to the 4th minus 32y to the 5th. So for now, it seems like maybe a lot of work, but if I was to ask you to do this, that's going to have 22 terms in our answer. To actually multiply that out would be a heck ton of work. You can make your own observations. That's great. How many terms are in the expansion? Well, our terms are always one more. So here's our power. Our number of terms is going to be plus 1. So determine the 6th term of 2x plus y to the power of 9. So this, again, we could do our whole binomial theorem just like we did up here and count 1, 2, 3, 4, 5, 6. But we can also use the formula that was on this page. This tells us our term number. So if we want to find the 6th term, so our formula is tk plus 1 equals nck times x n minus k y to the k. So the 6th term, so that's our term. Our term is k plus 1. So in this case, k is equal to 5. So we are looking for the 6th term. So n is our power. Our k is 5 times our x term is right there. Our power minus 5. Our y term, which is this, in this case it happens to be y to the power of k. So 126 times, this would be 2 to the power of 4, which is 16x to the 4th, y to the 5th, which gives us 2016 x to the 4th, y to the 5th. For determining the 7th term, so again, k plus 1, k is equal to 6. This is our x term. This is our y term. So we're looking for the 7th term. We've got 9c, our k is 6, times our x term, which is there, to the power of 9 minus 6, times our y term, which is negative 3y to the power of k, which is 6. So 9c6, oops, that's 9. 9c6 is 84 times x to the 3 times 3 to the power of 6 is 729, and it's an even power, so that's going to be positive. Y to the 6th, so that times 84 is 61,236 x cubed y to the 6th. Ta-da! Have fun. Happy practicing.